Good morning. So in this video, I'm going to discuss the Pitot Tube. So generally, a Pitot Tube is used to measure the volumetric flow of gases. So let me show you the PowerPoint. Okay, so as you can see, a double liquid manometer is inserted inside a pipe. So it measures the pressure difference on the wall of the pipe right here and on the middle. So aside from pipe, pitot tube are also used in airplanes. No, it is used to measure the velocity of the air flowing against the airplane. So there's a certain instance that a a bee, no, a bee accidentally gets into a pitot tube of an airplane. And that particular bee causes the crash of that particular commercial plane, causes the deaths of several hundreds of people. So basically, the pressure inside the pipe is generally greater than the pressure at the wall of the pipe. So meron tayo ditong height reading, no? So the equation of the Pitot tube, you can find this on the handbook, page 10-11, no, is this one. So basically the velocity in the middle, which is actually the maximum velocity, is equals to C, this is the constant, 0.98, square root of 2gc, this is, if you have the English system, this is 32.174 pound mass times feet per second squared per pound force. For SI system, this is simply 1. So times PT minus PS. So PT is the pressure at the middle. PS is the pressure at the surface, no? Tapos this is the density of the gas flowing through the pipe. Okay? So in using this equation, probably you should use this should result in this should result in pound in Pascal in SI system, in Pascal in SI system. Tapos you divide it by kilogram per cubic meter. So basically you will have um, meters in SI system, tapos uh, this will result to meter squared second squared. If you take this square root, this will result to meter per second in SI system. In the case of the English system, uh, you're supposed to get feet, no? So if the pressure is in pound mass or pound force per feet squared, the GC will convert that to feet squared per second squared, and then when you take the square root, it will give feet per second. So basically, if you're asking me how this is derived, basically this comes from the Bernoulli equation, This comes from the Bernoulli equation. So this is the pressure of the gas inside the pipe. Generally, this is calculated using the equation of density, So this is density of the gas. So that would be PM over RT. Papamama over that. Pressure times the molar mass of the gas divided by R divided by the absolute temperature, Because these two are given. Okay, so once you get the B max or the B nut right here, the next step is you're going to calculate the Reynolds number. So you're going to calculate, generally if you get the Bmax, you're going to get the dB rho max, no? dB rho max, dB rho max divided by mu. Ito yung kanyang value. After calculating that, you will get from this chart, you will get the ratio of the average velocity divided by Bmax right here on the left, no? So when you get that value using the calculated Bmax, you can calculate the average velocity. So from the average velocity, you can easily calculate the volumetric flow of the gas. Kasi 'di ba the volumetric flow is basically velocity times the area. Okay? So ganun lang 'yun, ano? So actually medyo relatively mas complicated yung calculation ng Pitot Tube compared sa mga na-discuss na natin earlier. Okay, so this is problem 8.6. You can find this on the 7th edition. You can also find this on the 5th edition. So air at 200 degrees Fahrenheit is forced through a long circular flue 36 inches in diameter. A Pitot tube reading is taken at the center of the flue at a sufficient distance from flow disturbances to ensure normal velocity distribution. The Pitot reading is 0.54 inch water. Okay, so that's the pressure at the middle of the tank. It's greater than by 0.54. As you can see, it's inch water. Yung pa rin yung isang kakaiba dito. Hindi siya inch mercury, inch water siya. So mababa lang talaga yung pressure drop kahit nakita nyo ang laki-laki na nung 536 inches kasi gas. Tsaka relatively hindi talaga ganun kalaki kasi pressure drop lang yun, wala namang kayong reduction in the diameter of the pipe, nilagay nyo lamang sa gitna against that pressure in the surface. So the static pressure at the point of measurement is 15.25 inch of water. Again, this is inch of water. So you must be careful, hindi siya inch mercury. The coefficient of the Pitot tube is 0.98, so that's your C. Calculate the flow of air in cubic feet per minute, measured at 60 degrees Fahrenheit and barometric pressure of 29.92 inch or 760 millimeter mercury or 1 atmosphere. So ang pinapahanap niya yung cubic feet per minute. Ang tawag dito sa condition na to, yung 60 degrees Fahrenheit tapos 1 atmosphere, ang tawag diyan SATP. So ibig sabihin ng SATP, standard ambient temperature pressure, no? This is your SATP, Itong 60 degrees Fahrenheit tapos 1 atmosphere. This is SATP. As opposed to STP, So this is standard ambient temperature pressure. So as you can see, actually ito yung difference. Ito yung major difference. Kasi sa STP, this is 0. 32 degrees Fahrenheit sa STP. Dito, 60 degrees Fahrenheit. Kasi kumbaga, pag nagkukwentahan sila kung magkano babayaran, usually based yan sa SATP. Per cubic feet, ganun yung bayaran, Ganun yung presyuhan sa US, So that's why they have this SATP. Kaya ito yung pinapa-calculate sa inyo. So how do you solve this problem? First, kailangan nyo munang i-calculate yung pressure. So try to convert this pressure to atmosphere. Bakit ba kailangan natin yung pressure? Kasi yung pressure, gagamitin natin yun sa pagka-calculate ng density. Okay? Yung density, kailangan natin yung density. Kasi ang density ay papamama over rat, di ba? So pag nakuha nyo na itong density, ito yung second step. Yung pangatlo, gagamitin nyo na yung you need to calculate Bmax. Bmax in a Pitot tube. So Bmax in a Pitot tube is simply equal to C times square root of 2GC. Tapos pressure difference between the middle and the surface. Tapos i-divide nyo to ng density. Yung density na makukuha nyo dito. So this is the third step. Pag nakuha nyo na yung Bmax, ang pang-apat na step, kakalculate nyo yung Reynolds number. So pag nakuha nyo na yung Reynolds number, pang-limang step, makukuha nyo yung ratio ng average velocity at saka ng Bmax. Dun sa graph. No? And then pag nakuha nyo na yung B, yun, makakalculate nyo na yung volumetric flow rate, yung Q. Kasi ang Q ay, ang volumetric flow rate ay B times area. So gagamitin nyo yung 36 inch. So relatively mahaba siya, no? Compared dun sa mga naging solution na natin. Pero familiarization lang naman yun. So let's try to solve this in the whiteboard. Kasi mahaba nga. So first, let's try to calculate pressure. Ano? So pressure is in the atmosphere. Ano? So if you still remember, sa problem nakalagay 15.25 inch of water. So that's gauge pressure. Ano? So kasi gagamitin natin ito sa papamama over rat. So kailangan absolute yun. Ano? So mag-a-add tayo ng, so this is step 1. Ano? Yung 1 atmosphere, i-add natin yung 15.25 inch of water. So, rho GH lang naman yan, di ba? Rho GH. Ito ay water. So, ganun pa rin. Ano? 1 atmosphere. Ito yung P atmosphere. Ano itong 1 atmosphere? Plus, yung density ng water is 1,000 kilogram per cubic meter. So, please try to watch out. Parang madalang kasi tayong mag-calculate na ang unit ng pressure ay inch of water. Ano? So actually sa gases lang yun. Tapos sa Pitot Tube ko rin nga lang na-encounter. G is simply 9.81 meter per second squared. Tapos yung H natin is 15.25 inch of water. So ang gagawin ko dito, i-divide ko siya ng 1 inch. I-multiply ko pala, no? 2.54 centimeter. Yung centi gagawin kong 10 to the minus 2. So this is in meter per inch. So if you still remember, this will become Pascal. So para maging atmosphere, I'm going to divide the whole term by 101,325. Okay? So you're supposed to get pressure equal to 1.0375, ano? Atmosphere. Okay. So next, let's try to calculate the density of the gas, no? So the density of the gas is equals to Papa Mama over Rat. This is the default equation, no? So the pressure, we have calculated it to be 1.0375. Let me check. Okay, tama naman. So pressure is 1.0375 atmosphere. Tapos ang molar mass ng air kasi yung gas natin is 29. So this is according to McCabe. This is according to McCabe, it's 29. So this is in grams per mole of air. So I'm going to use R is 0.08206. Alam niyo ng unit nito. And then ang temperature natin, it is stated na 200 degrees Fahrenheit. So yung 200 degrees Fahrenheit, mag-a-add ako ng 460 para ma-convert siya sa Rankine. Tapos i-divide ko siya ng 1.8 para maging Kelvin. Ano? Kasi ito, Kelvin yung unit dito. So you're supposed to get density. The density is supposed to be equal to, pinutin nyo lang sa calculator, grams per liter pa yung lalabas dito. Ano? So this is approximately 1, saktong 1, ano, 0.9999961. So this is approximately 1. I don't know kung sinadya nilang ganun yung density, ano. So ang unit nito ay, kung tandaan nyo, this is supposed to be grams per liter. Kasi, di ba, magka-cancel out lahat yung unit, this is in Kelvin. Magka-cancel out yan. Itong atmosphere, magka-cancel out dito. No? So, matitira dyan, ano na lang, grams per liter. So we need to convert this, kasi nga English tayo, we need to convert this to pound mass per cubic feet. So yung gram, this is simply 454 gram per pound mass. Madali yan, ano? Yung liter medyo mahirap, so ginugel ko, and then ito yung nakita kong conversion factor, ano, 28.32. 28.32. So this is 28.32. This is liters per cubic feet. So yun, magka-cancel out ito, yung grams magka-cancel out din. So this will give you the pound mass per cubic feet density. Ano? So density is 28.32 divided by 454. So this is approximately 0.0624. 0.0624. 24. So this is pound mass per cubic feet. Okay, so next we're going to use the we can now use the number step 3, we can now use the Pitot equation, so that would be B max is equals to C times square root of 2GC PT, this is pressure, PO minus the density. Ito na-calculate natin dito. So just substitute everything. You have 0.98 times the square root of 2 times 32.174. Hindi natin siguro yung unit. Malaki naman, So this is pound mass feet per second squared per pound force. Ito yung gravitational conversion. You're converting pound mass feet per second squared to pound force. Tapos itong PT minus P sub O, ito yung pressure difference between sa surface at saka doon sa middle. So sa problem nakalagay na yan, 0.54, 0.54 inch. 0.54 inch water. So basically, ang gagawin ko dito, i-divide ko siya ng 12 inch per feet. Tapos, i-multiply ko siya ng density ng water. So, ang density ng water ay 62.4, di ba? Pound mass per cubic feet. So, ito magka-cancel out. Water itong dalawa, Tapos yun, magka-cancel out din yung feet. So, ito ay magiging feet squared na lang. Tapos, when I divide this with density, ang density natin ay ito, yung 0.06224. I hope you can still follow. Ito ay pound mass per cubic feet. So as you can see, yung units natin ay, let's see kung makakancel natin. Ano? Ito magka-cancel out ito. Okay. Tapos, ito, ano, magka-cancel out din to. So, pit squared na lang yung matitira. Di ba? So, ito, magka-cancel out ito. So, pit squared per second is squared. So, pag kinuha nyo yung square, magiging pit per second dyan. Ito hindi nag-cancel. Okay, anyway, ito na lang, ano, yung pound mass per pound force. So, this will give a feet per second result. Ano? So, ang Bmax natin, we're going to use the calculator. Let's confirm this. Yung square nito yung buong term, ano? So, 0.98 times square root. Tapos sa taas, 2 times 32.174. Tapos times 0.54 divided by 12. This is inch of water. Then kasi atang inch of water meron yung ano eh. Meron siyang, pero magkakaroon yung feet pala, yung feet na height, meron yung ano, pound force feet per pound mass. Kaya magkakansel, mawawala yung pound mass pound force na ano units, ano? So, yun yung explanation na. Okay? So, I hope you're getting what I'm trying to say. Tandaan nyo pa, yung unit na feet ng pressure, actually ano yun, pound force foot per pound mass. Kaya mawawala yung pound mass pound force na nasa GC. Okay, so times 62.4 all over 0.0624. So, yun, you're supposed to get 52.7 feet per second. So that's your Bmax, 52.7. Okay, na ano yun, na-explain ko dito. ito kasing feet na unit ng pressure. Actually, yung feet na unit ng pressure, ano yan, pound force foot per pound mass. Ganun yan. So, ito in effect, ito yung magka-cancel out dito. Kaya ang matitira, feet per second na lang. Pag kinuha niyo square. No? I hope you're following. Yun yung isang challenge talaga dito sa ano eh. Sa fluid mechanics. Actually, tsaka sa thermodynamics. Yung cancellation ng units. Ano? Hindi naman pwedeng basta ka na lang parang blindly gagamitin mo na lang yung mga conversion factor. Dapat talaga nakaka-cancel out mo. Okay? So with this, so far, ang susunod na dito, the fourth step is to calculate the Reynolds number. So I'm going to clear this up. Pwede nyo naman balikan sa video. I'm going to clear this up. Tapos, gusto nyo, balikan nyo. Basically, ang gagawin ko, magka-calculate ako ng Reynolds number. Tapos gagamitin ko yung chart to get the ratio of B average and B max. So, this is step number 4. And then the maximum Reynolds number is dB rho, no? Divided by the viscosity. So sa problem naman, given naman yung viscosity, ano? So ang D natin, if you still remember, this is 36 inch. So gagawin ko itong feet, i-divide ko ng 12 inch per feet. Okay? Tapos yung ating velocity, actually yung Bmax yung gagamitin ko dito, ano? Kaya NRE max yan. So ito yung 52.7 feet per second. Tapos yung density natin is 0.0624. This is in pound mass per cubic feet. Tapos yung viscosity This is 0.022 centipua. Ito yung given sa problem. So gagamitan natin ng conversion factor. I hope you still remember the 6.72 times 10 to the minus 4. So this converts centipua to pound mass per feet per second. No? Mawala yan. Tapos yun, really unitless na to. Ano? So you're supposed to get NRE max equal to 3 times 52.7 times 0.064 0.022 times 6.72. So 667,305. Ano? 667,000. 305. So sa libro, ni-round up na lang niya ito ng 670,000. Okay. So with this, let me share the PowerPoint again. Ano, para makita natin yung chart. Para makuha natin yung rate, yung ratio ng average B sa Bmax. Okay? So ito yung chart, ano? So 67,000. This is 100,000. This is 200,000. For 200, 300, 400, 500. So, again, 200, 300, 400, 500. So this is the 600,000, ano? So extend nyo lamang doon. Sa NRE max tayo. Extend nyo lang doon. So mga dito, ano? So lampas siya dito sa line na to. So this line, yung line is 0.85. So ang gagamitin natin mga 0.86, no? So ayun, ano? 0.86. Pag pumunta kayo dito, andito yan. A little bit above 0.85, di ba? 0.9, 0.8. So it's a little bit above 0.85. So ang ano natin, ang average velocity, maximum velocity ratio ay 0.86. Okay, so let me share again a whiteboard. Tuloy natin, ano? So kung ang number 4. So step number 5, calculate natin yung yung Bmax, yung average velocity. So ang average velocity divided by Bmax ay 0.86. So, na-calculate natin ang average, ang Bmax natin 52.7 feet per second. So, ang average velocity natin ay approximately equal sa 45.3, no? So finally, let's calculate the volumetric flow rate. Ang volumetric flow rate is basically V times A, no? Yun nga lang, kung natatandaan nyo pa yung check-out nyo, kasi iba yung gusto nyong iba yung gusto nyang temperature at saka pressure. So ito, yung makakalculate nyo dito, yung actual, no, 200 degrees Fahrenheit tapos 1.0375 atmosphere. Yung pag ganyan lang, pag ganyan kasimple, ano? Pero ang gusto niya kasi 60 degrees Fahrenheit and 1 atmosphere. So magkakaroon tayo ng temperature factor, no? Tandaan niyo pa ba 'yon? 'Di ba pag may temperature factor, generally meron tayong temperature, yung actual, parang final at saka initial, ano? Ganun. Tapos meron din tayong pressure factor. So Meron ding pressure. Okay. Ganyan. Ganyan yung mangyayari. Tandaan nyo pa, ginawa natin, I think ginawa natin ito sa checkout. Ano? Yung technique ni Hemmelblau. Okay? So let's try to solve this one. Ang kukunin nating Q ay 60 degrees Fahrenheit tapos 1 atmosphere. Yung flow rate na yan. Ano? Na-imagine nyo naman, di ba? Ang pag-gases kasi, nagbabago yung flow rate, yung volumetric flow rate, depende yan sa pressure at saka sa temperature. Kaya meron tayong temperature, pressure at saka pressure factor. Ano? Ito, probably, anyway, actually hindi yan PF over PI, hindi yan TF over TI. Iniisip siya kung lumaki o lumiit, ano kung tumaas o bumaba. Anyway, you're going to see it later.
Okay to. Okay.
So, halimbawa, ito yung ating B, average B, so 45.3 feet per second. Tapos yung area natin is pi over 4 lang naman, ano? And then ang diameter ng ating pipe is 36 inch. So ito, i-divide lang natin ng 12, tapos squared natin. In regular solution, ito, okay na to. This will give you cubic feet per second. Pero this cubic feet per second is at 200 degrees Fahrenheit and 1.0375 atmosphere. So gusto natin ganito. So yun munang temperature factor. Pag ang temperature bumaba, anong mangyayari sa volume? Di ba liliit siya? So pag liliit siya, pag minultiply nyo ng temperature factor, dapat less than 1 yung result nun. So 60 plus 460, dapat rangkay na, no? Divided by 200 plus 460. This ratio is less than 1. Yun namang sa yun namang sa pressure. Yung pressure natin ngayon 1.0375 tapos naging 1 atmosphere na. So bumaba. Pag bumaba ang pressure, nag-expand siya. So dapat yung pressure factor ay mas greater than 1. Ano? Actually, this is supposed to be PI over PF. Mas tama yun. Ano? Okay? Ayoko kasi mag-memorize. Actually, hindi ako nag-memorize. Ako ganun ako. Iniisip ko siya. Pero kung gusto niyo mag-memorize, ganyan yung temperature at saka pressure factor. Okay? So, pag bumaba ang pressure, iniisip ko, lalaki yung volume. Okay? So, pag lumaki yung volume, yung 1.0375 atmosphere, nasa taas, yung 1 atmosphere nasa baba. And then just use the calculator to solve this. Ano? Let's use the calculator. 45.3 times shift side divided by 4 times 9 times ratio ng 60 plus 460 divided by 200 plus 460 times 1.0375. So I'm getting yun. Ang nasa libro kasi ay per minute, ano? So meron pang per second kasi to, ano? So lalagyan ko pa ng ito per second. Na nagko-convert ko pa yun sa minute. So there are 60 seconds per 1 minute. So times 60. Yun. We're supposed to get 15,700, no? 15,700 cubic feet per minute. Tama naman. Ito yung nasa libro. Ano? 15,700 cubic feet per minute. Okay? So, relatively medyo mahaba pero every now and then lumalabas ang Pitot Tube, no? Sa board exam namin. So kailangan nyo pa rin. Tsaka yung another thing here, yung medyo bago, yung inch water, no? Yung inch water. So ngayon nyo lang medyo nakita yung inch water na pressure unit. Tsaka yun, na-review naman kayo sa Reynolds number. Okay na rin naman yun, ano? Tsaka na-introduce kayo sa equation ng Pitot Tube. So sana meron kayong ma-retain kung mag-board exam kayo. So, hanggang dito na lang to, ano? Probably the last video for this course is the weir, no? Post ko na lang to, tapos hintayin na lang yung video.